Hi, everybody. Mrs. Bixler here, and I am here to talk to you about section 10.4 from your textbook, which is all about two special binomial multiplications. So hopefully you feel right now really comfortable with foiling. So this is the first of two of those special multiplications. So I want you now to pause the video and go ahead and foil each one of these out. All right, so we're back. So let's go through the foiling process. When you did your first terms, you had x times x, which is x squared. Your outer two terms is negative 4x. Your inner two terms is positive 4x. And your last two terms is negative 16. Let's do that for the next one, and then we'll go ahead and simplify. So I got x squared for my first. Outer is negative 6x, inner is positive 6x, and last is negative 36. And then for the last one, my first two terms is x squared. My outer two terms gives me negative 2x, inner 2x, and outer negative 4. So if we go through and we simplify here, I see that in each one of these, see how this negative 4x and positive 4x, they drop out. And it happens every time. So when you simplify these, you wind up getting x squared minus 16, x squared minus 36, and x squared minus 4. Interesting. Do you see where this name, the difference of two squares is, and where this comes from? I've got a perfect square right here and a perfect square right here. And I'm finding the difference between the two of them. Remember, that's a fancy word for subtraction. So the difference of two squares comes from things that look like this. So if we were to do this guy out, if we foiled this out, we would get x squared first. Outer would be positive 10x. Inner would be negative 10x. And then my last would be negative 100. So if I went through and simplified, oh shoot, my middle terms drop out and I'm left with x squared minus a hundo. So if we wanted to do this faster, and that's all this is, it's just sort of a way to be a little bit more efficient, as opposed to going through and foiling things out, blah, 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 blah. Instead, I can look at this problem and I can say, oh, I know that this is going to give me a product that's the difference of two squares. And so I know that it's this number squared, and then the second number squared, and then I take the difference of them. That's it. So if I gave you a problem like this, go ahead and try to do this, pause the video, and try to do this using the difference of two squares pattern. All right, so we're back. Now, all you had to do was take that first term and square it, take the second term and square it, and then find the difference. And that's it. And I wrote down here, worst case scenario, you totally forget the difference of two square patterns and you don't worry about it because you can foil it out. You can always foil. So if you see this and you're like, oh, I think this is something special, I can't remember, go ahead and foil it out. And I guarantee you're going to foil it out and then be like, it's the difference of two squares. So if I foiled this out, look what I get. My first two terms give me x squared. My outer two terms give me 9x. My inner two terms give me negative 9x. And my last two terms give me negative 81. And then looky-loo, these middle guys drop out, and I'm left with x squared minus 81. Cool? All right. So keeping that in mind, I want you to pause the video and decide which one of these products is the difference of two squares. All right, so the criteria is this one and this one have to be perfect squares. So this is a perfect square, this is a perfect square, this is a perfect square, this is a perfect square. Okay, so we're good there. Here's a perfect square. 35 is not a perfect square, so this one's out. So I know now that I'm just looking at the top two. But if you have the word difference here, you know it's got to be subtraction. So this guy is also out. So the only one that is a true difference of two squares is that one up at the top. So now we're going to compare two different things. So on the left, you see we've got x plus 10 times x minus 10. And by now, you should say, oh, wait a second. I think this is going to give me a difference of two squares. I think this is going to give me x squared and 100, and then I'm going to take the difference of them. Awesome. The one on the right looks really similar, except this one, instead of a positive and a negative, I have two positives here. And so I can combine these and I can make it look like this. These are equivalent, right? X plus 10 times x plus 10 is the same thing as x plus 10 squared, as we talked about in our foiling video. So that x plus 10 squared, this is going to give us a different special product. And this is a product that we call a perfect square trinomial. So whenever you have a situation like this, we've got x plus 6 squared. Remember, this is not x squared plus 6 squared. No, 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 no. Remember that x plus 6 squared is x plus 6 times x plus 6. So I want you to pause the video and go ahead and FOIL that guy out. All right, so we're back and hopefully you FOILed this out. So I'm going to do it too, just to double check. So I get my first two terms are x squared. My outer two terms are 6x and then, ooh, another 6x, nice. And then a little 36. Now, do you notice how these middle two terms, they don't drop out? I don't have a positive and a negative like I did for difference of two squares. But I wind up getting x squared plus 12x plus 36. This trinomial right here, this is what we call a perfect square trinomial. And you're going to learn why in a second. So I want you to pause the video and FOIL this one out. Okay, so we're back. I'm going to write this out. So x minus 5 times x minus 5. And I'm also going to FOIL this out. So I got x squared minus 5x minus another 5x and then plus 25. And if I simplify here, I get x squared minus 10x plus 25. This again is what we call a perfect square trinomial. If you didn't get this, pause the video, go back, and make sure you feel comfortable with getting this product. Okay, so what I have done on this next slide is I have taken three problems and I have given you what the perfect square trinomial is. So I FOILed them out for you. I did all the hard work, and then I simplified it. And these three answers were what I got for those trinomials. And I want you to pause the video, and I want you to see if there's a connection between these two numbers and what you see in this trinomial. So again, if there's a connection between these two numbers and what you see in this trinomial, a connection between these two numbers and what you see in this trinomial. All right, so let's take a peek here. So what I see is I see that this number squared is first, and then this number squared is second. And that's true for all of these. Look, x squared, 7 squared, x squared, and 9 squared. Cool. So those are two out of the three terms. But now if I look at this center term, this is a little tricky. So where did this 8 come from? Where did this 14 come from? And where did this 18 come from? It's kind of tricky. So that 8 came from twice 4 and twice 7 and twice 9. And then you just multiplied it by that first term again. So if we were to look at this bottom one, this x plus 3 squared, and go through with this perfect square trinomial pattern, watch. I take my first term and I square it. I take my second term and I square it again. So that's, again, 2 out of 3 of our terms. And then for our center term, we're going to take twice 3, so 2 times 3, which we know is 6, and then we're going to multiply it by this first term. And you're done. I know that seems kind of crazy, but what I want you to do on this next slide is I want you to pause it and try this on your own using our pattern. All right, so let's do it out. So I've got this guy squared. I've got this guy squared. And remember, -7 times -7 is a positive 49. And then remember, our center term is going to be 2 times 7, and then times that first term. So remember, though, it's not a positive 7. This one's going to be a -7. So I get a negative 14x in the middle. And then this becomes a plus 49. Now, again, a little worst case scenario here, don't fret. If you're looking at this and you're like, I think it's something special, but I don't know, I'm freaking out, don't worry. Write it twice and foil that sucker out. Foil. Foil always saves the day. And I promise if you foil it out, you're going to wind up getting the exact same thing. So I got x squared minus 7x minus another 7x and then plus 49. And look, if you simplify that, you wind up getting the exact same thing. So what we talked about today is we talked about 2 special products that you get from multiplying binomials. The first one was what we called the difference of 2 squares. So if I saw a problem like this, I could multiply it together really quickly, and I could say, oh, I know that this is going to give me x squared minus 16. Worst case scenario, I forgot how to do that. I don't know what I'm talking about, and I can go ahead and foil, and I promise you, you're going to wind up getting, if you do foiling correctly, you're going to wind up getting the same thing. And then on the right, we talked about a second special product, and this is called a perfect square trinomial. So this forms a perfect square trinomial. Remember, you take the first term and you square it, you take the second term and you square it, and then you do twice these 2 terms together. So 2 times 4 times x, which is going to give me an 8x. All right, that's it. Good luck on the work, and I'll see you guys soon. Thanks.